Hello guys, I'm trying to record this video for a while, but I can't really feel myself confident. So sorry if I do mistakes while I'm presenting you guys to this paper, which is from Proxemics Theory to Socially Aware Navigation by Rios Martinez and his colleagues. And this is the paper. So to start with, okay, I'm sorry. Okay. To start with, what does proxemics mean? Proxemics is basically the study of people that people feel it necessarily to set between themselves and others. So I'm going to cover these topics: introduction, social behavior and comfort, proxemics, human management of space, social robotics, and finally the conclusion. Okay, the use of service and companion robots in our homes and workplaces offers us many possibilities for mobile robotics. But for these applications to succeed, the robots must adapt their behaviors to meet social expectations, as you can guess. Okay, so from that page, you can see the classic robot navigation and the socially aware robot navigation as a whole piece. So compared to a classical navigation framework made of navigation strategies in dynamic environments, a perception system and robust constraints, a socially aware robot navigation framework must manage a social layer. So as you can see here, our methods are social signal processing, semantics of space, and behavior prediction in order to adapt social awareness. Okay, so robots must follow social conventions for safe and understandable behavior during navigation. And understanding human expectations in the comfort space, a relationship requires knowledge from the socially field of human spatial behavior. You see Edward Hall here, and I'm going to talk about his research. Okay, so in order to design a strategy for leading a robot safely in an environment populated by humans and at the same time preserving their comfort, it's necessary to explore how humans manage their surrounding space when they navigate and how their comfort could be affected by the motion of other pedestrians. Hall suggested that humans have modified the general proxemics rules followed by animals, permitting a more complex social behavior. So, anthropologist Edward Hall suggests that humans have modified general proxemics rules followed by animals, allowing for more complex social behavior. Unlike animals, humans do not typically attack or escape when others invade their personal space. And instead, social cues are used to notify others about the instead of the affected individuals. So, despite these differences in perspective, ethological studies on domestic animals sharing space with humans can provide insights for social robotics. Let's talk about social behavior and comfort. And automatic interpretation of human nonverbal communication is still very challenging. According to many authors, the nonverbal communication represents more than 60% of the communication between two people or between one speaker and a group of listeners. And an emerging domain called social signal processing aims to give the machines the ability to sense and understand that kind of social messages. In that framework, social messages are defined in terms of social signals and social cues. Okay, so what are social cues and social signals? As you can see here, eye expressions, tone of voice, facial expressions, and body language can all be examples of social cues. And the social cue means that describes a set of verbal or nonverbal messages And human social signals are acts or structures that influence the behavior or internal state of other individuals. They're adaptive to the perceiver's response. But the main challenge is link the social cues with the right social signals, actually. And let's continue. I'm always doing the wrong click, I'm sorry. So this is a table from the paper. This table links social cues to appropriate social signals, as you can see here. And let's talk about that one. For instance, the social cue of hand gestures is related to the social signal of emotion. It's indeed possible to detect a person's stress by observing the quick repetitive motion of his or her fingers. And as you may understand from my hand gestures and from my facial expressions, I'm a little bit nervous. You can understand that from my face and my hands, maybe. Maybe that can be an example of social cues and social signals as well. Okay, let's move on. Okay, so social cues or social signals, and so these cues can give useful evidence to assess the degree of concordance between robot navigation and social conventions. However, regarding the visible social cues, one needs to be aware on the fact that the semantics of the body language varies with cultures. And I said that thing over here. The important thing is link the social cues with the right social signals. Okay, let's move on. Okay, so factors influencing the psychological comfort. Let's move on that topic with that topic. And many theories on psychological comfort explain the relation between distance, visual behaviors, and comfort. The relation between intrusion and discomfort is observed as linear, indicating that each increment of intrusion produces a comparable increment in discomfort. When threat is high, distances tend to be larger. In casual conversations, people respect space related to that activity, and only participants can go inside this space without causing discomfort. And in subjects rated intermediate distances between 4 and 8 feet, I don't really remember the actual measure in meters, but I guess they were like 1.2 meters to 2.3 meters. I remember like that, but I will put the real measures right there. And these distances as most comfortable, preferable, and appropriate for interaction situations. I'm sorry for my pronunciation. Okay, go on. Okay, so people have a certain level of comfort when it comes to intimacy, which includes factors like how close someone is, how much they smile, etc. If someone invades that comfort zone, social cues will signal discomfort. And however, the comfort is subjective and cannot be measured directly by sensors. So, to develop useful models for social robotics, researchers can study how factors such as distance, posture, and visual behavior affect human comfort. Okay, again, Hall, and let's move on our next topic, which is proxemics, human management of space. And I just put the Hall's, Edward Hall's another photo over there. And you will see Hall very often on that presentation. Okay, thanks to him I'm doing this presentation right now. Okay, so proxemics is the study of spatial distances individuals maintain in various social and interpersonal situations. and these distances vary depending on environmental or cultural factors, as you know. And Hall observed the existence of certain unwritten rules that lead individuals to maintain distances from others and lead others to respect this distance. Okay, so for example, in a crowded elevator, people still tend to stand a certain distance apart from each other, and this can be an example of unwritten rules. Okay, let's talk about theory of mind, and I think that is a very complex topic. When I was preparing this presentation, we didn't really cover the topic theory of mind in our lectures, so it was very challenging for me to understand what that is. So if I will mention it about very shortly, and theory of mind is a cognitive skill that allows individuals to interpret and predict the behavior of others, understand social relationships, and engage in effective communication. And it's and here you are seeing two little kids, because theory of mind shows that this theory begins with the very early childhood and moves on and develops itself. It has been proposed that the management of space done by a single person is different than the one done by a group of people. And the term we space is the result of the coordinated engagement of interactants and is different from the perspective commonly studied of an individual acting agent. And a socially aware navigation strategy should manage four kinds of space: the ones related to a single person, to groups of people interacting, to human object interaction, and to human robot interaction. And let's start with spaces related to individuals and personal space. And a personal space is the region around humans that they actively maintain, into which others cannot intrude without causing discomfort. And you can see these spaces in that figure. As you can see here, these circles represent the personal space for I'm sorry. Okay, sorry for interrupting. And these circles represent the personal spaces for each individuals in that picture. And again, Hall says that there is a natural arrangement of people motivated by the respect of individual personal spaces, which are represented using circles. Here is an example figure of personal spaces, and you can see concentric circles, egg shape, bigger in the front. Okay, bigger in the front, as you can see, and ellipse shape, and lastly shape smaller in the dominant side. It's actually a symmetric shape, I can say that. Concentric circles is just, basically the circles that you all know. And it is possible to classify this space around a person with respect to social interactions in four specific zones whose distances from human body are listed there. And I think that these distances are different from the ones that we learned in our lectures. However, in the paper, they were just like that, so I added these zones like that: the public zone, the social zone, the personal zone, and lastly the intimate zone. And here is a figure for the circles and who can be in that circles for an individual. Okay, so let's move on with egg shape, and the egg shape is used to illustrate how people are more sensitive to intrusions into their frontal space. So it is very long definition over here, but if I would summarize that, I would say concentric ellipses used to describe how pedestrians move through a space while interacting with each other. Let's move on with asymmetric shape. And asymmetric shape refers to recent research that has shown that personal space does not vary with walking speed when avoiding obstacles and is smaller on the pedestrian's dominant side. When passing through narrow spaces, people evaluate the ratio between the size of the passage and the width of their body. Okay, I imagined that description like that. I'm not sure if I'm telling you something right, but I'm always doing that movement when I'm passing through some other pedestrians to avoid, collision. It might be that, that movement. I hope this example is correct anyway. Okay, so experiments have also shown that personal space is dynamic and dependent on the situation. Okay, so let's talk about information process space. And many current models of pedestrian movements share the common element of the information process space. And recent experiments have shown that this space has a cone shape, not semicircle or semicircle as previously thought. And these experiments involved tracking the gaze patterns of walking pedestrians and revealed that the information process space is located directly in front of the pedestrians with a small lateral distance. So, addition to this, eye contact strongly influences the information process space, and pedestrians can maintain eye contact until they're about 2.5 meters apart, and after which they typically look down, and I always do that as well. Here are the figures that I mentioned you. This is the information process space. Okay, so let's read the descriptions of that figures. And okay, a pedestrian is more interested in the exact front to detect obstacles and other pedestrians in order to calculate his or her next moves. Shape and measures obtained for the information process space, and the pedestrians is represented by circle here. Okay, so let's talk about another topic, which is space related to groups of people. And results converge to the idea that people keep more space around the group than the mere addition of single personal spaces. It is therefore important to study groups separately. So humans react to a societal regulation through the concepts of focused and unfocused interactions. So I'm going to give the definitions of focused and unfocused interactions. And focused interaction occurs. Okay, focused interaction occurs when individuals agree to sustain a single focus of cognitive and visual attention. And conversations are focused interactions because people share a common focus of attention with a shared common space. And unfocused interactions are interpersonal communications resulting solely by virtue of an individual being in another's presence. And in unfocused interactions, people negotiate their positions with others by means of nonverbal behaviors. And the concepts of space and formations permit to detect conversations. And let's talk about the O-space concept. Okay, here you can clearly see the O-space and P-space or that figure. And let's give the definitions of these terms. The O-space is the joint or shared area dedicated to the main activity established by groups in focused interaction. Only participants can enter into it, they protect it, and others tend to respect it. Otherwise, it would be rude and weird, I think. And the P space is the space surrounding the O space, which is used for the placement of the participants and their personal belongings. And social robots can take benefits from that knowledge to identify social interactions in the closed environment. The term affirmation is used to designate the system of spatial orientation, arrangement, and postural behaviors maintained by people respecting their own space. And the main functions of the affirmations are the regulation of social participation and the protection of the interaction against external circumstances. The shape of the affirmation varies according to the number of persons involved, their interpersonal relationship, and the attentional focus, and lastly, the environmental constraints. Okay, so I would like to show the figure before these explanations over here. And this figure illustrates how the position and orientation of people can help to decide what groups are in conversation and where would be located the O space. Okay, so let's go back to the other slide. And two people conversing usually stand in one of the 6 following formations as you see before. N shape, vis-a-vis, V shape, L shape, C shape, and lastly side by side. And as an example, N shape, vis-a-vis, and V shape are more frequent in open spaces, not heavily used by pedestrians. Let's look at them. N shape, vis-a-vis, and V shape. The 3 of them here. And the vis-a-vis formation, also referred as face-to-face, is the basic mode of human society, human sociality. And experiments show that passing between a vis-a-vis formation is more comfortable if the passer knows well the people in formation. Otherwise, it would be very weird, I think. Okay. When more than 2 people are in conversation in absence of furniture or other obstacles, they commonly exhibit a circular shape arrangement, as you can see in these figures right there. Let's talk about the activity and the affordance spaces. A human activity defines a virtual amount of space which is recognized and respected by the others. Okay, and first of all, I would like to show you the figures. Okay, this is the activity space and this is the affordance space. You may want to look them first. Let's go back. And okay, so a human activity defines a virtual amount of space which is recognized and respected by the others. As a consequence, 2 more concepts must be incorporated in a socially aware strategy: the activity and the affordance spaces. The activity space is a social space linked to actions performed by agents, humans. And the notion implies a geometric space but does not give an explicit definition for the shape. It can vary from activity to activity, I think. And the affordance space is a social space related to a potential activity provided by the environment. Here is the activity space and here is the affordance space. And people try to bypass this activity space in order to not interrupt the activity. However, crossing by the affordance space is okay, but you shouldn't block the affordance area in order to block somebody's activities. Okay, so affordance spaces are also potential activity spaces, as you can imagine. Okay, so for a robot to navigate semantically, it must connect perceived geometrical features of the environment with semantic information about objects. But however, this task is complicated by the fact that sensor-based perception is objective, meanwhile human perception of space is subjective. So to achieve semantic robot navigation, it's necessary to infer based on context and defined concepts which portions of empty space are restricted to a robot navigation. And let's move on. Robots and proxemics. And Research in robotics heavily lead to a set of social rules that will probably govern the robots' physical behaviors when they interact with humans. And it seems that the behavior of people sharing spaces with robots is not so different from the way they behave with other people. And proxemics factors can be listed like that: speed, appearance, direction of approach, and other factors. And let's look at them. The experiments presented by indicate that human subjects feel uncomfortable only with the robot's fast approach speeds. The comfortable speeds are between 0.254 meters per second and 0.381 meters per second, while the uncomfortable fast speed is 1 meter per second. Because of that, I think because of that, people want to protect themselves in order to any emergency situation, any dangerous situation, things like that, from the robots. So people want to be faster. Okay, so our next subtopic is appearance, and the appearance and size of the robot must be considered in the robot's behaviors modeling. They observe humans approached and avoided by a robot, first by using the base robot only and then by adding a humanoid body to the base. Their results show that people who prefer the humanoid robot accept closer distances than the other. And direction of approach or gaze direction. According to the experiments, an indirect approach seemed to be preferred by experimented subjects. An indirect approach is a less threatening behavior because the threat of contact has been reduced. In experiments done, participants to which a robot has to bring an object perceive the robot motion threatening and aggressive when the robot uses a direct frontal approach. And frontal approach directions are perceived as comfortable while farthermost directions are perceived as uncomfortable. Okay, our other topic is social robotics. In the robotic literature, we can observe the growing interest in research topics, including behavior of humans and its impact in robotic tasks. Okay, so sociality refers to the ways individuals interact to satisfy needs that cannot be alone, and social robots must engage in a natural interaction with humans and develop relationships by displaying availability and friendly attitudes. This requires knowing how to initiate an interaction with a human. And for social robots to effectively interact with humans, they must be proactive and behave in expected ways. And this requires the robot to have an internal understanding and adaptable social model of human society. A socially aware navigation is a strategy exhibited by a social robot which identifies and follows social conventions in order to preserve a comfortable interactions with humans. The resulting behavior is predictable. The resulting behavior is predictable, adaptable, and easily understood by humans. And from the robot's point of view, the humans are no longer perceived only as dynamic obstacles but also as social entities. From the figure, as you can understand, the related work on socially aware navigation is divided into focused interaction and unfocused interaction. And let's begin with unfocused interaction. And in unfocused interactions, people and robots share the same environment, and robots must negotiate their position with others by means of nonverbal behaviors or by the knowledge of rules in social spaces. And let's talk about the subtopics of unfocused interaction. Minimizing probability of encounter. And in experiments, a spatial affordance map is used to learn and predict spatio-temporal behavior of people in a house. Okay, so such map serves as a cost model for planning robot paths, which minimize the probability of encounter with people. The researchers propose a method for smooth collision avoidance of humans by using the social force model to determine whether a pedestrian intends to avoid a collision with the robot or not. Passing people, and inspired by human spatial behaviors, design of an office guide robot for social interaction studies. Paper presents a robot motion control which includes a module that achieves a people passing behavior in corridors, pass a person by the right, and a generalized framework for representing social conventions as components of a constraint optimization problem is presented and used for path planning and navigation. Staying in line, researchers develop a model for the personal space of people standing in line in order to build a strategy for a robot to do the same task. Their personal space model is used both to detect the end of a line and to determine how much space to leave between the robot and the person in front of it. And let's move on with focus interaction. In focus interactions, people and robots share a common focus of attention when executing their activity. In this kind of interaction, the robot is expected to adapt naturally and dynamically to changes in the interaction. Okay, let's begin with approaching humans. What abilities robots will need to successfully retrieve missing informations from humans? Okay, a socially aware navigation is employed to request help from human passers-by. An approach based on Bezier curves is implemented as an nonlinear optimization problem with the objective to find the velocity profile for the Bezier path under constraints enhancing social acceptance. Okay, following people and walking side by side. Compare two person following behaviors, one following the exact path of the person and the other following in the direction of the person. And they concluded that the second strategy is the most human-like behavior, as you may guess. I think it was one of the questions in our exam. I remember like that. And the focused and unfocused interaction. Some works have proposed techniques capable of some works have proposed techniques capable of fulfill the two kinds of interaction. Based on the person's pose and position, the adaptive system detects if a person seeks an interaction with the robot or not. And this work is presented as a basis for human-aware navigation, and navigation is implemented using human-centered potential fields. Well, that was it. As a conclusion, I will go back to the paper. And this paper covers important concepts related to social conventions from sociology and robotics perspectives. And Proxemics is the most investigated field to improve robot sociality in navigation. But human management of space is complex and context dependent, and social robots need to identify activity spaces from sensors data and consider not only personal space but also information process space and space of interaction navigation schemes. And I think that was all for that paper. Thank you for listening me, guys. I hope I was clear. However, you can ask me questions about the paper if you'd like to. Okay, so see you guys. Bye.